Let's see about constructor overloading. Constructor overloading is nothing but if I say I can create the constructor, right? So this is the default constructor. So this is constructor is nothing but name. This is the method like other methods which is always public, okay, by default. And there could be other method which can be parameterized. So this is parameterized constructor, okay. So here also the same concept applies for the constructor methods as well for all overloading. So it doesn't depend on the return type, access modifier or static. So in case of constructor there is nothing called static or static, so it doesn't depend on the access and return type. So it only depends on the type of the parameter and number of parameters in a method. So number of parameters from one method to another method, it can same and can differ. If it is same, then type of the parameter should be different. So it means that bottom line, it should have the different method signature. Name can be same. That is all about method overloading. Let's go to the next concept next. So next concept is about garbage collection. This is very important phenomena process inside the Java virtual machine. So garbage collection is kind of a memory management. So memory management is a term which is needed in Java programming. So memory management is done by Java virtual machine. So memory management is nothing but when you create the object, it allocates some memory into Java memory. It allocates some space in Java memory, and once you use it, Java virtual machine deallocates the space required for the object which is now not referenced, which is now not valid. So it will deallocate that space. So why do we need it? We need garbage collection because you in your program you are keep on creating the objects. So that is keep on occupying the space in Java memory. So that is the place. There could be, if there is no Java memory management, then you can reach a situation where your available memory, your whole RAM available, that will be exhausted. So all the space available in the RAM can be occupied by using your program. So your program cannot run. So because your program needs some space to run. So like your operating system is running, your some process is running inside your computer that needs some memory. So like that your Java program needs some memory. So once you are running a program, you are creating a lot of objects that is occupying some space in Java memory. So that requires to be deallocated. That space needs to be clear so that space can be available for the other objects. So that is the place where garbage collection comes into picture. And garbage collection is a memory management process. That process is performed by Java virtual machine. As a programmer, you don't have much control on how Java virtual machine does the memory management. As a programmer, what we can do best, we can write a program in such a way that it can help JVM to do the better garbage collection. So garbage collection cannot be forced. You can simply, there is something called system.gc. System.gc is a hint to JVM that saying that please do garbage collection. But this is a very soft request. Your request doesn't guarantee that it will fulfilled. So JVM garbage collection cannot be forced. How it works? How the garbage collection works? Let's see. So in this slide you can see that the top bar shows that live objects, okay, and red one shows that orange one shows that unreferenced object. So once you create the object and using it, at till that time it is a referenced object. That object is being referenced in your program by some other objects. Once that part is over, when that job is over, that object is unreferenced object. So when you allocate a memory and when you are not referenced here, you have to garbage collection, it marks that those kind of objects in orange color, and as shown in the orange color, it marks those objects which are unreferenced. Once it marks the object, finally it collects those marked spaces, then clean them so that it will be available for the other objects. But that is the very old kind of fashion of doing the garbage collection, and that is not efficient, because that's number of objects that program creates is a huge number. So there should be some better and more intelligent process to be that process should be available to the garbage collection. So if we talk about Java memory has different divisions. So it is very high level divided into heap and permission space. So heap is basically a place a place in the memory where your object will be space will be created when your class is instantiated or object is created. When object is created, it occupies some space in the heap memory. So in the heap memory we have different section. First section is called young generation, then we have old generation, then permanent generation. So young generation is the place that is the place which has again divided into Eden and Survivor 0 and Survivor 1. Old generation has tenured and permanent generation has permanent. So permanent generation uses the metadata of the class and methods whatever is going to execute in the program. So Eden generation is the place where object when the moment you create the object, it will come into Eden, and it will, if it is short lived, if it is very small, if it is referenced in very small time, it will be available in young generation, and that is the place where it will do the garbage collection. If that object is having, if that the age of that object is more, it means that it is long lived, then it will move to the old generation where garbage collection will be performed. So garbage collection will happen at two places. It depends on the life of the object. So young generation where objects memory is allocated, that is called minor garbage collection. It deallocates memory quickly if it is, because it is short lived objects are stored here, and that is easy to do the deallocation quickly. So if it is aged, if that your object, the reference of your object is for longer duration, then it will move to the old generation, and that is a place where major garbage collection happens. Permanent generation, as I said, it contains metadata required by JVM describing classes and methods in the application that used at runtime when JVM decides that it has to do the garbage collection, then it will perform the garbage collection. So garbage collection cannot be forced. Finalize method. Finalize method is a method in an object. Whenever you create a class and create the instantiate that class and create one object of that class, what happens, it allocates into memory, and after the once reference is done, when it is unreferenced, then it will be marked for deallocation. So before doing the deallocation, if object has finalized method, the finalized method will be called. So every object, every class that stands from object. So every class in Java is object. So finalize method is the method available in the object class. So let's see here. Let's take any example. So if you see here, I am creating. Okay, let's take one example. I create test finalize. So test finalize, I am creating one main method. Okay, and I say test finalize tf is equal to new test finalize. Okay, so in this method I have one method called finalize. So finalize is a method which is available in your object. So I can use the same finalize method what is available in the object R. So that's what it turns super. I will tell you when I about super, when I will tell you about inheritance. So here finalize method will be called when object will be deallocated or when it will be garbage collected. So that's how here we have created the object of that class, and once that will be deallocated, this method will be called. Okay, so that is place you can write the logic to deallocate any resource that is used in your Java program. Okay, so if you run this program, so it, it depends on the JVM. It needs to do the finalize or not. If it is doing finalize, then it will print this statement whatever you want to write. So that is like kind of a request to do the to Java virtual machine to perform the action of your finalize method, but it doesn't guarantee that whatever you want to finalize it will do that. Okay, let's move to the next. Let's talk about inner classes. So inner classes are the classes which are available in a class. So the class which is outside, that is called outer class. The classes which are inside, it can be more than one, those are inner class or classes. So the purpose of inner classes are, so inner classes are kind of a again object oriented model. Suppose you have an object internally which has a certain property which can be clubbed into another object which belongs to the parent object. That is a place where you need to think about inner classes. So suppose I have class employee, and employee internally has some employee address. So in employee class I can create one inner class as a employee address. So I can create employee address outside of the class. That is not technically a problem, but the logical thinking about inner classes are about we try to put related class into one class. If that class is only applicable to the outer class, then we may require to create the inner class. Otherwise, it is not required to create the inner class. So once is to create the inner class, there could be decision that you need to make, that either you need to create public class, a private class, or a static class. So if you are using private class, so the accessibility of your class will be inside the outer class only. If it is public class, it can be inside the outer class as well as outside of outer class. If it is static class, it depends, you can club static with private or static with public. So that way you create, and if it is static class, you can use that class statically in that outer class. Let's see few example. Try to see. Let's create one new class, say inner classes.